Welcome, everyone. It's nice to see so many of you here. My name is Kenneth. I am Danish, so we're like the second most happy people in the world. We used to be number one, but apparently the people in Norway are more happy than we are. So I work for this small company called Intel. We make processors. They sit inside laptops and things like that. And you might wonder, why are we working on the web? Well, the web is this like really amazing platform where you can create these experiences. It's an open platform. It means that it can work everywhere. It can work on your phones. It can work on Windows laptops. It also powers a lot of the cloud. So the web is really, really important for us. I work on a browser called Chrome, so I'm a web developer, and I'm also like a browser engineer. But I also work on standards in the W3C. So I'm trying to help inform the web. I'm also part of the Google Developer Program, so I'm a Google Developers expert in web. So we're here today to talk about smart devices. So the first question you might ask yourself is, what is a smart device? Is a device smart if I need to pick up my phone to turn off the light? Like, let me unlock my phone. Where's that app again? Oh, there it is. Loading. Oh, somewhere there. Turn off light. That's not really smart. Then it's smart as you just have like a light switch on the wall you can just click. So when you're going to create these smart devices, you need to solve real issues. You also need to be around when you need it, like that light switch. And you need to be easy to use, and which is also called low friction. You don't want to confuse the user. And you especially don't want to force people to download an app when they really need to do something, right that moment. People want to do things now, right now, not 10 minutes from now, especially not when traveling. Imagine you being, for instance, you're traveling, let's say you're in Ukraine, you want to pay for your car, parking, and the first thing to do is like, hey, well, you need to install this app. First of all, you might not have data, or it might be very expensive, and it takes you forever. No, you just want to pay for that. In the future, a lot of people is talking about ambient computing. They said that everything will be online. So you can imagine, you have your smart lights, you have your TV screen, you have your speakers, but that doesn't scale with apps. You don't have room for that. It kind of reminds you of how it was with Windows. Where is that icon I'm looking for? And it's turning to become the same on phones. We have all these different icons, way too many of them. You lack the overview, and then you get these updates for things that you never use. Think about it. You install all these apps, you might maybe use them once or twice, and every week it says, oh, there's 5 new updates. It's downloading. It makes your phone slow, it uses your data plan. Yeah, it's not really useful. But let's look at some of these usages. When talking about smart devices, I categorize them into 3 groups. The devices you use every single day, like turning on the lights. Some you'll use like occasionally. It could be, for instance, your refrigerator. It's fine during winter, but when it's summer, you really want those beers to be cold, so you want to adjust the temperature. And it could be these things that you use like once in a lifetime, like pay for parking in another country. You might wonder, is there a better model? We want the low friction and ease of use. And everyone gets this on the web. You have something called a URL. It's an address. You just put it in, and then you can experience things. Go to a website, like a news website. You've never been there before. Write the URL, and there you are. You don't need to wait for downloading like 60 megabytes without even knowing whether it's a site you want to use in the future. But for this to work, we also need the web to be fast. Otherwise, people say it's not the nice experience. They want to use those mobile apps. So on the Chrome team, we have worked really, really hard on making Chrome fast for users. So we've focused on speed. So this is like some of the new standards we have worked on. HTTP 2 push, something called service work, or the purple pattern streams, a lot of things going on there. We have a new thing, you've probably heard about it, called service workers. So service worker is this magic thing. It sits between your browser and the cloud and the servers. So sometimes you might not have any connectivity. You can think of it of kind of like a proxy in between, like a mini server, if you will. It allows you, when trying to access an app or a website, it might ask the service worker, hey, do you already have that image available? Then let me just show that. Or maybe I should check on the server whether there's a new one and an update for future usages. Or if I'm offline, just show whatever I have available. It allows you to flexibly create new experiences in a way you want it to work. Unfortunately, it also means that the nice dinosaur is a thing of the past. This will slowly die. But the conclusion is that web is actually ready. We can work offline. We can be fast and responsive. So look at this experience. I'm clicking on a link, and there we go. Super smooth experience. You might say, that can't be the web. I didn't see any address bar. It was fast, and there was like an icon on the home screen. That's not what we're used to. This is a new experience we call progressive web apps. It allows people or websites that take the right vitamins to be added to the home screen, to be launched without showing the address bar. If there is engagement, they progressively become more app-like. If you want to learn more about that, there's a website. I will be sharing my slides later, so you have all these links available. If you want to learn more about progressive web apps, there's also a new great book written by a friend of mine, and I'm very happy because it comes with a quote from me. So the web is really, really good for low time, like for one-time usages, especially because it has low friction. Everything is just a URL away. It can be handy when you want it to be. If you really engage with this website on a regular basis, you can add it to your home screen. It could be that icon. And that might be useful if you just need it, for instance, for turning on the light or changing the light color to become red in the evening. It's just an icon away, but only if you want it to be. There's also less clutter because you only add those things you really need and really care about. And the major advantage of the web is that it's safe, because it's built to be safe. Because on the web, we just surf around. You just enter random web pages. You get a link from a friend, you just click on it. You don't want to be scared or think, oh, whoa, am I getting a virus now? Is it going to steal all my account, all my money? No, the web is designed, all the APIs is designed with safety in mind. But you might ask yourself, but all these kind of devices, they kind of live outside of the sandbox. They're not on the web. But the web can do that too, and let's have a look at how that works. One thing you should keep in mind, that I'm talking about like a few different technologies, is that users and companies don't mind. These technologies work well together. Just choose what makes the most sense for you. So I'm going to start by talking about something called Bluetooth and something called USB. So Bluetooth is a widely used protocol that with the newest version is not using a lot of power, and it works over the air. It's wireless. Very useful. I have one such device right here with me, if anyone wants to see it later. It's relatively cheap, it's pretty easy to use, and it comes with beacon functionality, which means that the device can announce that it exists in the surrounding. Some of the disadvantages of using Bluetooth is security. You're just sending radio waves. So you should probably encrypt what you're sending so you don't have like people sniffing. The device is also not powered externally, so they'll have to have a battery or maybe be actually powered. They're not powered over any protocol or line. There could also be a problem with stability and speed, especially in concrete. If you make, for instance, a museum, you have a lot of concrete walls, the signals might not be passed around so easily. So here's an example of how web Bluetooth works. So there's a candle in the middle and a web app. It just selects the device, and now there's already that experience. Really, really frictionless. These are things you can do on the web today. So this is the web Bluetooth standard, and it's implemented in Chrome and I believe Opera for the moment. And also implementing support for it on the Samsung Internet browser, on Samsung phones. It's based on Bluetooth 4, so this is what people call low energy. Officially, it's called Bluetooth Smart. It's an easy-to-use modern web API, so it uses something called promises and something called typed array. Something to keep in mind is that it doesn't support the legacy Bluetooth. And you can only connect to peripherals. It's like the Bluetooth itself is only central, not peripheral. It means your phone cannot act as a Bluetooth device. It can only connect to devices. So this is the standard where you can find out where it's implemented and how well it works. Bluetooth, because it's one of these like scary things, it requires you to have a safe connection. So it's secure HTTP. It also requires a user gesture. And the reason for that is that when you surf around the web, you don't want suddenly a web page to access devices around you without you knowing about it. So you need to press somewhere on the screen, for instance like a button, and then could connect to the device. It works like this. Here the user is clicking in the middle. It will pop up a dialog. He'll select his polar heart rate belt, and it connects to the device and starts showing the heart rate. Really, really easy to use from a user's perspective. Let's look a little bit at the code to see how easy it is. You don't need to follow all of these code samples. They will be online. But let me just show you how simple it is. You basically call navigator.bluetooth.requestDevice. This has to happen on a user gesture. So for instance, a click on a button or click on an image. Then you can filter for like devices. Here I'm filtering for services called battery service. Sometimes with existing devices, this might become a UUID like this. When that happens, it will return you a promise with something that can resolve in the future. When that happens, you can act on it, or if it fails, like the user clicked outside of the dialog, you can catch an error. You can also filter for names. Some of these devices might have multiple services. So if you have a device that has service A, and another device would have service A and B, and you want to create a web experience that allows you to connect to both of these devices, then you also want, when you connect to the device that has service A and B, you also want to be able to connect to service B. In order for that to be possible, you need to list it as an optional service. So this is just one thing to keep in mind. This is how Bluetooth Low Energy works. You have a profile with services inside which contains characteristics. As you probably know JavaScript, you can think of a service like an object in JavaScript. And objects in JavaScript have properties, so characteristics you can think of as properties. So this could be like a string or like a Boolean. But as this is a binary protocol, on existing devices, people tend to use like arrays, like typed arrays, like byte strings, and they can actually sometimes pack multiple values into one characteristic. When you have a device, you connect to the GATT profile. So this thing, the GATT profile. When that happens, you can start interacting with the device. So I can, for instance, get a characteristic called battery level. When I get that, I can read the value. As this value is a typed array, I'll need to actually extract the value. Here is an unsigned integer of 8-bit. You can also write to, if the protocol supports it, writing is just as easy. But on Bluetooth, you often have values that change over time, like you just saw with the heart rate. So in these cases, you need to listen to notifications. So you call start notification and add an event listener, which is going to be called every time that value changes. It's actually pretty easy to use when you understand the basics. I was talking about bootstrapping and the beacon functionality. So Bluetooth devices allow devices to send out a beacon to explain that they're available. We're talking about the web here, so Google, they created a standard on top of that called Eddystone, which allows these devices to actually broadcast a URL, basically an address to a website or web experience. So this is the old UI, but it looks something like this. Today, this is integrated in Android Nearby. It will show that something is around you. You can click on it, and it will open and load that website. It could look something like this. This is actually an implementation they've done in London, where you're at the bus stop, they will have a Bluetooth device. You're not interacting with the device itself, it just sends out a URL. You click on that, and you get the experience where you can see, like, where am I, when is the next bus coming, etc. So you can imagine this something like you're paying for your car. It will just broadcast the URL, you click on it, and you can start paying. Really, really frictionless. To learn more about Bluetooth, here's a URL where you can get started. Let's now look at USB. So USB, just like Bluetooth, is widely used. It's cheap because it's just based on cables. It's more secure because it actually requires to be connected. So you could take one of these cable or maybe the plug and put it behind a lock. For instance, in a factory, you might not want users to walk in with a phone and be able to connect to one of your very, very expensive machines. This can also power devices, and because it's connected, it can transfer a lot more data using a stable connection. You can say, depending on your use case, that the disadvantage is that it's actually cables. USB has no radio interference, and as I said, the connector could be locked behind the hatch if you need it to be. Like I said before, users and companies don't care how stuff works, it should just work. Both technologies work fine, choose whatever makes the most sense for you. So I'm showing one example of what you could accomplish with these technologies. Here I have a device, it's like an IoT device, it's connected with a temperature sensor and an LED. It's currently not plugged in. So this is a USB connection, I'm plugging it in. It will take a bit of, like 3 seconds to boot. So you see this light in it now, it got power. It show up a dialog. I'm now pressing on that dialog, which launches a URL. Here I added like a small editor where you can code JavaScript, because this device can run JavaScript. I'm showing you have the web USB permission available, and there's the code. If I press run, that should start by showing the temperature on the screen, which you should see in just a second. There you go. Now it's running JavaScript straight from the browser. Just to show that this is live, I select the RGB, another example, and press run. Deploys instantly to the device. These are the experiences you can do on the web today. So it showed a device running JavaScript. It bootstrapped by showing the dialog to the website, and the device was powered over USB itself. Web Bluetooth is just one protocol. With USB, you have 3 options. Something called bulk, something called interrupt, and something called isochronous. So bulk transfers is the fastest. Like, you bulk things together, but you don't have guaranteed timing. So that might be a problem. For instance, if this was a keyboard, then you really don't want that, because you want to see what you type when you type it. So this is mostly used for printers and serial connections. So interrupt is exactly for that keyboard mouse use case. When things happen, it should send. So it's not as fast as bulk, but it guarantees maximum latency. Isochronous is for streaming. For instance, think of a webcam. You don't want it to be delayed. You just want to send as much data as possible. And if it drops a few frames, no one cares. With Web USB, which is standard for connected USB on the web, you can get further security and restriction by adding a few USB headers. That's how it works with USB. These are optional. They are required if you want to see like the pop-up to show a URL, because you kind of need to put that URL somewhere. And you can also restrict which sites, like what devices, which sites can access that device. So it looks like something like this. There are few issues with USB on different platforms, especially if you try to become a serial device. This is because a lot of these devices have existing drivers. So I'm just listing these on some of these slides if you need to work with USB. So let's look at one of example with how to connect to USB device. Just like with Bluetooth, you do request device with a filter, you get a device, this is how USB works. You need to select the configuration, claim an interface, and then you can start to transfer things. So here I'm transferring in data, which I'm writing out. In JavaScript today, this is using something called promises. That's why you see the .then, 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 .then. In JavaScript today, we have something called async await, which makes this code much easier to read and write. So instead of like, it will just stop execution at this point. When that happens, when that fulfills, it will go to the next line. This makes it really, really easy to code these things in JavaScript. WebUSB is shipping in the latest version of Chrome. It ships on Linux, Mac, Windows, and it even works on Android. To get started, here's a link where you can learn more. Wow, that was a lot of things. But there's a lot more going on the web with connectivity to devices. A lot of companies, they need to track stuff. It's very common. You have a small shop, you have your products, and you need to track them. So how can you do that? Well, there's different solutions for that. It could be like a barcode scanner. Maybe a Bluetooth beacon is the best solution. It will show you where the device is. Maybe it can even light up when you select it. Maybe it's an NFC tag because you want people actually to have a physical connection to the device. Or sometimes you just want to use these QR codes because they're very, very cheap and you can just print them. We are working on bringing all of these features to the web. So behind the flag in Chrome, there's something called the Shape Detection API. It has a much bigger scope, like it will even be able to detect like people in pictures and stuff like that, but it can also be used to detect barcodes in images and video streams. Another option is to use NFC. So this is actually one of the standards I've worked on myself. So here's a simple example. I don't know if you know NFC. NFC works the way that you have devices that are actively powered. This would be something like your phone. And you have these devices like, I actually think I have, it could be a device like this. Maybe it's not powered, it's just a thing. But if you touch them together, your phone will generate an electronic field that will power up that device. And at that point that happens, you can read data and you can write to it. So here I'm writing, I'm pushing data directly to the tag when that happens. Here's another example. It's more complex. What I do is that I try to watch. This is for like reading data. I watch for a read where that happens. If it's empty, I write to it. I just give it JSON data. So I just write first name Kenneth. If it's not empty, I instead call this process message, which is going to read the data. So the second time it's going to read and write out hello, Kenneth. If there was an image, it could even store an image inside this tag. I think this is pretty cool, and even the founder of the web, Sir Tim Berners-Lee, thought this was a cool idea. So I made a small example to show you how this works. So here I have my progressive web app. It's actually written in Polymer, a very small app. It's like a shopping list. Here I'm writing, I believe I'm writing milk. I press write. I put down it on this tag, and now it wrote milk to that tag. Just to show that it's working, like it added milk to the list. Now I'm writing cocoa, and it's moving on the table, so it's not working the first time. It failed, and there we go. Now it wrote cocoa. So now I can place this around my home. Like every time I'm needing like new dishwashing power or whatnot, I can just click on this with this app. These are things you can do on the web with NFC. But sometimes you need to connect to other devices in order to control and receive data. Something like a sensor. And my phone has plenty of sensors. So wouldn't it be nice if you could have an API where you could access these sensors on your phone, but also an API you could use if you're like programming like an IoT device using JavaScript. So we worked on this and created a new standard called Generic Sensor API. On top of this, we started adding different sensors, like a gyroscope, like a magnetometer, accelerometer, ambient light sensor, orientation sensor, and plenty more. Oh. When I started working on sensors, I thought it was really, really difficult to understand, like, how do I work with these sensors? How do I combine them? What can I do with them? I looked around to see if I could buy a book that would teach me all the basics, but I couldn't find any. So I went ahead and actually wrote an explainer. So if you have any interest in sensors, especially motion sensors, I have this explainer that gives you all the basics. Using generic sensors is really, really easy. All you do is to generate, you just call this new object like an accelerometer, and you can pass in some options. Here I'm setting the frequency. At this point, the device itself might not have this sensor, or it might not be able to fulfill the options. So that only happens when you actually call start. You can listen to an on-reading event, or you can just like connect it directly here and then actually deal with the data. So here is like one example. Here I'm taking two different sensors. I'm taking an accelerometer and a gyroscope and combining them to do something like an orientation sensor. This might look a bit complex, but this is a very common called a complementary filter. I'm just showing you that this is possible. You don't need to understand all the details of this example. So I have another example like I wanted to show, because I said like this API is made in a way that would work on the web in a web browser, but also for other devices. So I thought, well, we have this thing called Web Bluetooth. So wouldn't it be nice to take this very nice Daydream controller I got with my Daydream set and use that as the sensor? So I took my small demo. I connect to my, this works normally on the phone. I connect to my Daydream, and there you go. Using the exact same API. I exposed that in like maybe 50 lines of code. Very, very simple. So I said, hey, this is pretty cool. I can do this with other devices. So I found this one in my drawer, and this one, and I tried to do the same, just using Web Bluetooth. So, very, very simple and very powerful. So here I'm actually showing you the amount of code that took. So here I think this is on the device itself. This device runs JavaScript. So I'm using the exact same API. I'm just like listening to the gyroscope and accelerometer and like packaging the data, sending it over Bluetooth. On the other side, I unpackage it and expose them as these generic sensors. This is like 61 lines of code. That's all it took. So with this, I want to say that the web is really ready for these like app-like experiences. You can effortlessly connect to devices over Bluetooth and USB. Even NFC support and barcode readers are coming in the coming years. And generic sensors is actually becoming something called an origin trial in Chrome very soon. So if you've never heard about an origin trial, this is a new way that you can start using new APIs before they're widely available, before they're shipping. Basically, you go to a special website by Google and you sign up. You say, I want to be able to use this new API on my website for the next Chrome release. Then Google will give you a token. This token you put into your website as a meta tag or as part of the header. And every user going to your website will be able to use that new API through your service. But, of course, it's limited. If you go to a big scale like Facebook and you get more than 1 million users, they might cut it off. So you need to make sure that your site also works without this feature. basically, the web is ready, so let's go build the future. With that, I want to show you one quick example. Because I have this small little device. This is actually a web USB device done by a Googler. Very small. It has 2 lights on it. What happens now is you see this website. This is using web USB. I plug in the device. Maybe you can see it. Can you see the lights? And now I can actually, immediately I get the experience. And now I can change the color. I hope you can see it from down there. So these are things you can do on the web today. I find that's pretty amazing. So with that, I would like to say thank you. If you want to get these slides, this is the URL. You can also follow me on Twitter, where I'll be posting the slides momentarily. Thank you.